Hi everybody, I'm back with a new lesson. This time it's about pulse width modulation. Um, and so what is pulse width modulation? It's just a way of doing something in an analog way with a digital system. And so before we were doing our blink example, and all we could do was turn the LED on and off, which is digital, either 0 or 1, or in our case, 0 volts to 5 volts. But say we want to be able to do something in a continuous manner with every gradation between 0 and 1 or between 0 and 5 volts. This is where we need to use pulse width modulation. Okay, and so what we're going to be able to do is we're going to be able to change the brightness of an LED over a period of time. So it's going to fade from nothing up to a maximum brightness and then back down. So that's what we're going to do. And so the circuit that we're going to build for this is going to look very similar to the one that we did for the blink, except now instead of plugging into pin 13, we're going to plug into pin 9, which is a pulse width modulation pin. So when you're doing pulse width modulation, you need to plug it into the pin that is specific to that. And so if you look on the board, you can see that the 9 has a squiggly line next to it, and that's how you know that it's a pulse width modulation pin. Okay, so if we look over at the website, this is our site. So we have a few new things here. You've probably seen this blink video. So the examples for this section, this Arduino section, are going to be here. And for this video, we're going to go into Hardware Week 2 Tuesday, open it up, and then we're going to start with this fading example. And so I'm taking this lesson from the fading tutorial on Arduino. So if you want to follow along, you can open it up here. And see what you need. But I'm going to explain all this to you so we can see the schematic, which looks very similar to the blink. And the only difference is that this is pin 9. We still have a 220 ohm resistor. We still have an LED facing towards the ground. Let me go back. Okay. And then we can see their code. We'll look through that. This is what you need. Okay. And then if you want to learn a little bit more about pulse width modulation, you can go to this section here and it'll explain a little bit of how it works. It's really a way, and here we can see this chart. So if we have an analog write of 0 going to a pulse width modulation pin, we're sending 0 volts. If we have 25%, it's going to be, if we have 64, it's going to be on for 25% of each cycle. So that means that we're going to be giving it a 25% power, which will be, yeah, we can just think of it that as 25% strength. 127 is halfway between 0 and 255, which is our range. And so that's going to be 50%. And then if we want to do 100%, that's going to be 255. It's going to be on 100% of the time. And so you might recognize this this shape as being a square wave, and it is. And so when we're using pulse width modulation in Tone.js, it's similar, except that we're hearing it in the audio range instead of using it as a control signal like we are here. Okay, so you can read through this on your own time. So let's build the circuit. So I'm going to go back to the phone. To trust it. Okay, so I have my board here. So what's the first thing that we're going to do? We're going to plug the ground to our negative column, and then we're going to plug the 9-volt pulse width modulation to the positive column. And we're doing this just so we have enough room. So negative column, doesn't really matter which side you view. So I'm going to put it in the very furthest one. And then I'm going to go in to ground. See? Okay. And then I'm going to go in the positive one all the way down here, just so we're all the way out of the way. This is not going to be a very big circuit, but later on you're going to have bigger circuits, and you're going to want your ground and your power to be just out of the way. So now I'm going to go over here, and I'm going to plug it into this 9. Okay. So now we can see the whole thing. Okay. So now I'm going to take my my LED. So remember, there's a short leg and a long leg, and the short leg is going to go in the direction of the ground, and the long leg is going to go in the direction of the power. Or the signal, whatever signal you're sending to it. Okay, so I'm going to point the short leg up, and I'm just going to put it in over here. Okay, so we can see all of that. So now, between the long leg, the power side, and the power itself, I'm going to put a 220 ohm resistor. So, and that is an example of that. And just remember, you probably have one of these charts yourself, but I have this chart. So go check that out to find what color the 220 ohm resistors are, or you can use the calculator that I had mentioned in class. Okay, so now I'm going to put it in so that the one leg of the resistor is going to be on the same row as the long leg of the LED. Okay. So now the one leg of the resistor is touching, because remember, these columns on the side are connected, and the rows are all connected. So anything on the same row is going to be connected. So now this one leg of the resistor and the one leg of the LED are connected. These two legs of the resistor are not connected. They're not connected by these columns. They're disconnected, but they're connected by the resistor. And then we're going to plug the other end of the resistor to our power. Okay. And now we're going to complete our circuit by going to the other end of the LED. It can be any of the holes. It can be any of the holes that are connected to the negative end. And then we're just going to go to our our column that we set to be to go to ground. And so mine is already lighting up because I already made an example that's on the board. So just to remind you, if you had sent something to the board before, that's the thing that's going to show up. So maybe yours probably won't be doing anything because the blink was set to go to pin 13, but I had this example before just to see if that would work. But so this is how it's going to basically end up. Okay, so I'm going to switch over to either Arduino code, and then we're going to start actually coding this. Okay, there was a weird cut there because Arduino is sort of buggy with this video program, so you might see that happen relatively often. Okay, so the first thing that we need to do is set up a variable because we're going to use this. We're going to use the pin. We're going to set up a variable to address our pin because we're going to use it in multiple places. So the thing about Arduino code is that's different from JavaScript. JavaScript, when we define variables, we don't have to define types. But in this code, which is based on C, we need to define types. So for now, the two types that you really want to keep in mind are int and float. And int just refers to integer, which just means a number, a round number, like 1, 2, 3, 4, 5. And float is going to be a number that's a decimal. So here, we want to refer to a pin, and all the pins are going to be integers, so we say int. So we're going to say int LED pin equals 9, because we're referring to 9. We don't need to do anything in setup. We don't need to do a pin mode because the pulse modulation pins are only output pins. So we're going to go down to the loop, and let's just say analog, right? And then LED pin, and then let's just put in a value here, and we can just see on our boards that the value is going to change, that the brightness is going to change depending on what value we put in. So maybe I'll put like a 20. So I'm running it, okay. So I forgot to put in a semicolon. Semicolons are required in the Arduino language. Okay, it's done uploading. You can't see my board. I'm not going to switch back and forth until the very end, but it's very, very dim. It's basically not even on. So I'm going to go like halfway, like 150. So I suggest that you also try this just to see what's actually happening. Oh, so I'm having an issue. So I set LED pin to 0. That's not the pin that's plugged into, so let's fix that. Okay, now if you change that LED pin to the one we're actually using, pin 9, you'll see the brightness change. Okay, so now how do we actually fade it from one value to another? Because we're in a loop, we don't need to do any sort of weird set interval thing. This loop, this void loop just runs again and again and again, like the draw loop in P5. So we can just wrap it in a for loop. So that's what we're going to do. So we're going to say for int fade value equals 0. So we're going to, so just remember the range here is from 0 to 255 that we can send to our pin. We're gonna count until the fade value is less than or equal to 255. and we're gonna fade. We're gonna go by a count of 5. So this number can be sort of whatever you want. If it's a higher number, you're gonna get quicker fades, I think. Okay. So I'm gonna move this. Excuse my barking dog. And then I'm gonna put a delay. Because remember, to see any change actually happening, whenever you change something from one to another, you need to put in a delay or you won't actually see the change. It'll happen so quickly that you won't see it. Okay. So now, instead of the 150, I'm going to use our fade value. So now what you should see is the LED fading in a loop from nothing all the way up to 255, and then right when it gets all the way to the top, it just goes all the way back down. Right when it gets to the brightest that it can be, it just turns off, and then it starts the fading from 0 to 255 again. Okay, so the next part of this is, now that we can fade it from nothing to something, how do we fade it back the opposite direction? So maybe you can guess. If you can guess, pause the video and try to figure that out. But if you're not sure, what we're going to basically do is reverse this for loop. So we're going to say for and fade value equals 255. We're going to go back, because we are at 255. Now we're going to go back down. Fade value is less than or equal to 0. Fade value, now we're going to say minus equals 5. And in case you haven't seen the syntax before, plus equals, this just means add and assign at the same time. And minus equals, this should be an equal sign. Minus equals means subtract and assign at the same time. So now we're going to say analog right, LED pin, fade value. And then we're going to say delay 30. And then I'm going to run it again. And now what you should see is exactly the same as what I showed at the beginning of the lesson. And now what you could do is mess with these delays some. So if you had a higher number here, let's see what actually happens with 8500. It's going to take much, much, much longer to fade from one state to another. So this is how you sort of mess with the durations here. Okay, yeah, that's good for this lesson. All right, I'll see you on the next one.